All right, so last Friday we finished up introducing unit conversions where we're trying to change one unit, in this case dozens of eggs, into another unit, which in this case was total number of eggs. And with simple ones like this, you can just do it in your head. However, when we start getting into more advanced ones, you have to be very careful about how you set it up. The key thing to remember is you do need a conversion factor, which I have in that blue box there, where we relate one unit, in this case dozen, to another unit, eggs. And then we want to set it up so that our units cancel. So we cancel dozen in our first example, leaving the unit of eggs. So let's do a couple more examples. And we'll start getting into scientific ones now. So for our first example, I've got a measurement that's 1.83 kilograms. And I want to convert this to the unit of grams. All right, so we've got to find some way of relating these units together. So the easiest thing to do is to go up and pull out that unit conversion sheet. Hopefully this will open. There we go. And then find the unit conversion that is appropriate. All right, so in this one, if we look at it, 1 kilogram equals, oh wow, there's a typo on the right. I'm gonna have to fix that. This should be 10 to the third grams over here. So 1 kilogram is 10 to the third grams. So we need to use that as our unit conversion. And if you think you set it up correctly, give me a thumbs up. Another thing I really recommend when we do these is use the calculator you plan on using during your exam. I've seen students in class where they use their phone to do practice problems. I won't let you use a phone during the exam. And then when they get into an exam, they don't know how to use their calculator correctly. So let's do this together. I've got 1.83 kilograms. We're going to multiply by a conversion factor. Do I want kilograms as a unit to be on the top or the bottom of this conversion? Bottom, so that it cancels. We want grams to be on the top. And then we want to make sure that the right number is with the right unit, right? So we've got 1 paired with kilograms up here. So I'll put 1 with the kilogram unit down there. And then 10 to the third goes with grams, not 10 to the sixth. And then we can go ahead and type this into our calculator. And this would give you an answer, 1,830 grams. Another important thing when you're doing these unit conversions is to pay attention to sig figs, right? So we had 3 sig figs in our original measurement. That means our final answer should have 3 sig figs. Does it? Yeah, it looks like it has 3 sig figs. It's important to remember we don't count the 0. So don't count as sig fig. Why not? There's no decimal point shown. Another way we could write this would be 1.83 times 10 to the third grams. Whoop, uh-oh, where'd it go? Both of these answers have 3 sig figs. I would accept both to be correct in this situation. Does that make sense? All right, let's try another one. Let's say we have a person that weighs 162 pounds, and we want to figure out what this person weighs in grams. First thing we need to do is to find our unit conversion, right? So we could go to our sheet. We need to find the relationship between grams and pounds. And in this case, if we look on the top here, pounds isn't a SI unit, so it's not going to be in the first column. However, on the bottom, I've got other conversions for American units. And down here, it says 1 pound is 454 grams, right? So let's go ahead and write that down as our unit conversion. not too bad. And now we want to make sure we set up everything correctly. So I'll give you a minute and then check with your neighbor to see that you set it up correctly. Also pay attention to sig figs like we did before. Does anybody need more time on this one? All right, let's do this together. So we start out with the measurement that we have, which is 162 pounds. Let me make it black here. And then we multiply by a unit conversion, and do I want pounds on the top or bottom? On the bottom so that it cancels. And we'll put grams on the top. 1 goes with the pounds unit in our unit conversion. We can see that up here, right? And then 454 goes with the grams unit. So now we can go ahead and we can say pounds cancels. That leaves us with grams. And when I go ahead and type this into my calculator, I'm getting a number that is 73548 grams. Is that what everyone else got? All right, are we done? No. We've got to go back and assess our sig figs, right? So it looks like we started out with 3 sig figs. Our final answer has 5 sig figs, so it's not correct yet. What we need to do is convert this to 5 sig figs, or sorry, 3 sig figs. All right, so there's a few different ways we can do this. We could just say, all right, 735 with 2 zeros behind it, right? So we'd say, all right, count these first 3. This number, the 4, is below a 5, so we don't have to worry about rounding up anymore. So this one would work. We could take a look at this answer and we could say, all right, this one has 3 sig figs, so that looks good to me. Or we could write this in scientific notation. And it would be 7.35 times 10 to the what power? If you remember, we can take this imaginary decimal point, move it over how many spots? 4, exactly. So we could say 10 to the 4th grams. Either way, this gives us an answer with the appropriate number of sig figs. So when you do these problems on exams or in your homework, make sure you show your work. And then what I really like students to do is to box your final answer. Otherwise, it's just a big jumbled mess of numbers, and I'm not quite sure which one's your final answer. All right, let's do a couple more. All right, for this next one, got 124 kilograms. And we're going to go all the way to milligrams. All right, so now we need to go back to that sheet and find some sort of relationship between kilograms and something else. So let's go back and look. All right, we're doing an SI unit conversion. Oops, sorry, let me keep this as a 3 there. And it looks like kilo is in this column. So we don't have a relationship directly between kilograms and milligrams, but we do have one between kilograms and grams, right? So that's good enough. Let's go ahead and copy that down. So we'd say 1 kilogram equals 10 to the 3rd grams, right? However, we don't have a relationship yet between grams and milligrams, but we can go right back to that cheat sheet and try to find a relationship between grams and grams and milligrams. So let's go back up and cheat again. We'd say, all right, milligrams says 1 millimeter, or milligram in this case, would be 10 to the 3rd of something, or 10 to the negative 3, excuse me. So let's go back down. And then we would say 1 gram, or actually let's change this. 10 to the negative 3 grams equals 1 milligram. So that was our unit conversion that we found. So now we have everything we need to set up this problem. I'll give you a minute to work on this, but check with your neighbor and see if you're setting it up the same way as your neighbor. This one is harder. I just want to get a feel for how people are feeling about this. Give me a thumbs up if you are pretty confident that you got it. Thumbs down if you're completely lost, and then sideways thumb if you're just not quite sure. All right, that's okay. I think we're about on par for the course right now. So let's go ahead and break this down and work through it. So we're starting out with 124 kilograms. And then we're going to do a unit conversion. Do we want kilograms on the top or the bottom? On the bottom. All right, so what we'll do is we'll use this top unit conversion and we'll say, okay, kilograms should be on the bottom. That way it cancels. And then we've got a relationship between kilograms and grams. So grams will be the other unit that's on top, right? Okay, the unit here that's paired with the number that's paired with kilograms is 1. So I'll put that with the kilogram unit down here. And then 10 to the third is paired with grams, so I'll put that on the top so that it's still paired with grams. All right, so now we're in good shape. We've canceled out kilograms and kilograms. We're left with the unit of grams, which isn't quite what we want yet, right? So we might need a second unit conversion. All right, in the second unit conversion, we want to cancel out grams. So should grams go on the top or bottom? On the bottom. And the relationship that we have down here can relate grams to milligrams, so I'll put milligrams on the top. That way, when we do our canceling, you can see that we're left with our unit of milligrams left over, right? We need to plug in numbers now, though. All right, so it looks like up here we've got 1 paired with the milligram unit. So I'll put 1 right there. And then I've got 10 to the negative 3 paired with the grams. And now we can go ahead and plug this into our calculator. It is tricky with exponents, so I did want to show you how to type this into your calculator. What you can do is just write 124 times 10, and then there's that little up icon like that, right? You can do that, and then write 3 there. Another good thing I like doing anytime I'm working with exponents is to put in parentheses, right? So what you could do too, just to be extra careful, is to put in brackets around that in your calculator. So that takes care of our first calculator conversion. And then in the second one, we need to be really careful. So what we can do for this one is, again, use parentheses. And then we'll say 1 divided by, and then for the next one, you can say 10 raised. So again, that little up arrow. And then often with this one, I like to again do parentheses again. So this is more of a calculator challenge. Close that. So now I've got my negative 3 unit in there. And then we also want to close our brackets like that. And now when I go ahead and check my final answer, let's see. Got it in my notes here. I'm getting a large number. I'm getting 124 with 6 zeros. Is that what everyone else is getting? Okay, so it looks pretty good to me. We can go ahead and we can say, all right, our final answer with units would be 1, 2, 4, 1, 2, 3, 4, 5, 6 zeros with milligrams behind it. Let's double check our sig figs. We had 3 sig figs going in. Do we have 3 sig figs going out? I'd say so. The zeros on the far right don't count because there's no decimal. Alternatively, what you can do is scientific notation. Say 124 times 10 to the 6 milligrams. These are both equivalent, right? So again, I like to box my answers and then also show my units. Like I said, calculator errors are oftentimes the biggest hiccup that people have, so make sure you're comfortable using your calculator. And always, always, always show your work. What happens sometimes is students during an exam, they'll just spit out an answer at me, and it's wrong because they put it into their calculator incorrectly, and I can give them no points for that. If you show your work and it's set up correctly, but you spit out the wrong answer because maybe you didn't have a parentheses in the right spot, I'll give you majority credit. So always double check that you're showing your work, always double check that you're giving the appropriate number of sig figs, and then double check your calculator work as well. How many people want to do another problem like this one? Yeah, these are tricky, so let's do one more. And then we'll do some challenge ones. Let's do 1.54 centimeters. This time we'll go to nanometers. So you may again need to pull unit conversions. All right, let's try to do this as a class. Again, let's see a show of thumbs. Thumbs up if you're confident, thumbs down if you're lost, sideways thumb if you're not sure. All right, so it does look like a mix again. So let's first find our unit conversions. The first unit we have is centimeters. We can't directly convert from centimeters to nanometers given the sheet I gave you. What can we convert centimeters to? Meters. Okay, so if you go to that cheat sheet, you'd say 1 centimeter is equal to blank meters. What would go for this number right here? What was it? Yeah, 10 to the negative 2, right? So if you go up here, hopefully it'll load, and you look in this column, you can basically plug in that number with the base unit and it will convert it, right? So in this one, we're looking at 10 to the negative 2. So let's go back down and plug that in. So this would be 10 to the negative 2 meters, right? So it's 1/100th of a meter. All right, so that's one unit conversion we can use. All right, next unit we need to find a conversion for is nanometers. So 1 nanometer equals something meters. What should that number be? 10 to the negative 9, absolutely. Okay, so now we've got our 2 unit conversions from our cheat sheet. And like I said, you'll be able to use that cheat sheet on an exam or a quiz, but if you don't really know how to use it, it's not that helpful, right? So let's start plugging this in, and we can say 1.54 centimeters. We'll multiply. We want centimeters on the top or bottom? Bottom. 1 goes with the centimeter unit. We've got a relationship to meters, so I'll put that here. And then we'll do 10 to the negative 2, like that. Looks pretty good to me. And then we'll go ahead and put meters on the bottom because we've already canceled out centimeters, but now we need to cancel out meters. Put meters down here. And then I'll put nanometers on top. And for every 1 nanometer, it is 10 to the negative 9th meters, right? So now we've canceled out our meters units and we're left with nanometers. All right, so let's go ahead and try this in our calculator. So I haven't even done this yet. 10 to the negative 2 times and And I'm getting a number that is 154 with 5 zeros. Is that what other people are getting? Again, make sure that your calculator input is correct. You can also use other math tricks with this. We're not going to really dig into that. My biggest concern is that you're comfortable using your calculator. Alternatively, what you can do is do scientific notation. And like I said before, we could take this imaginary decimal point, move it how many spots over? 7. That makes this problem way more dramatic. And it looks like we had 3 sig figs going in, and we're getting 3 sig figs coming out, so it looks correct to me. Does that make sense? These are kind of tricky. The biggest thing, like I said, is setting it up so that you're not flip-flopping your unit conversions and that you're putting things into your calculator correctly. All right, let's do a few other tricky ones. And then we'll finish up with the challenge one before we head out. All right, this one's going to be a word problem. So what is the mass of 1.00 liters of gasoline and then I'll tell you that gasoline has a specific density of 0.703. Grams per milliliter. So this one's a little bit different. It's laid out as a word problem, but we're given a unit conversion, right? Specifically, the unit conversion that we're given is density. So how can we write that out as a unit conversion? Well, we could say for every 0.703 grams, we have 1 milliliter of gasoline, right? It's exactly the same. So this could be used as a unit conversion. Okay, I'm seeing another problem though. What's the other problem? Up here, we're given the volume in liters, but down here, the volume's in milliliters. So maybe we need to convert milliliters to liters. So I'll go ahead and say, all right, 1 milliliter is equal to some amount of liters, and what would that number be? Anybody want to throw out the number from the sheet? Yeah, 10 to the negative 3. If you go in that milli line, right, it says the exponential equivalent would be 10 to the negative 3. So now we've got both unit conversions. So really, density is another unit conversion that we can use in these problems. So now let's go ahead and try to set this one up. I'll give you a minute and then check with your neighbor. All right, just for the sake of time, let's try to do this one as a class. All right, so the first thing that we measured was we know that we have 1.00 liters of gasoline. So we start out with that. We want to cancel out liters, so I'm going to put that on the bottom so that it cancels. And then we've got a relationship between liters and milliliters as a unit conversion, right? So I'll put milliliters on top. That's this unit conversion down on the bottom, right? So will 10 to the negative 3 go on the top or the bottom? On the bottom, it's paired with the liter unit. So I'll say, all right, 10 to the negative 3 liters for every 1 milliliter. So now we've gone ahead and we've canceled out liters and used that lower unit conversion. All right, now what we want to do is convert from milliliters to grams. So I can go ahead and I can say, all right, we want to cancel out milliliters, so I'll put that on the bottom, and then grams on the top, and that will allow us to cancel out milliliters and leave us with the unit of grams. All right, and for our top unit conversion, it says that 0.703 grams are paired with 1 milliliter of gasoline, right? So we can go ahead and plug this into our calculator, and it should give you a answer that is 703 grams. Does this have the appropriate number of sig figs? Yeah, absolutely. We had 3 sig figs going in, we have 3 sig figs coming out. Does that make sense? Yeah.
Would it matter if we switched, if we did like 10 to the third, milliliters to 1 liter?
Sorry, say that again. So you're saying 10 to the third milliliters to 1 liter? Yeah, that's the exact same mathematical operation. Good question. Okay, let's do a challenge one before we leave. This is going to be the most complicated one I would ever throw at you. All right, does anybody know who the fastest person is on the planet? Over 100 meters, I should say. Anybody know? Usain Bolt, anybody? All right, so he's won a bunch of gold medals in the 100-meter dash and 200-meter dash. So Usain Bolt ran 100.00 meters in 9.58 seconds. What was his speed? I should say average speed because it wasn't the same the whole way through. In miles per hour. All right, and we've got a bunch of unit conversions. So first thing we could do is convert from seconds to hours, because up here we're looking at a unit of hours. So we know that 60 seconds is 1 minute. However, we want to go all the way to hours. So we'll say 60 minutes is 1 hour. So that's pretty useful. And then the next thing I'm noticing is our unit of distance. We've got 100 meters, and then we've got miles here. If we look at our cheat sheet, it says that 1 mile equals 1.61 kilometers. Right? That's in our cheat sheet as a unit conversion under other useful conversions for length. All right? But we don't want kilometers because we measured his distance in meters, right? So then we could say 1 kilometer equals 10 to the what meters? 10 to the third. So this one has 4 unit conversions. Pretty tricky. I'll give you a minute to work on this. Then check with your neighbor to see if you can apply all 4 of these unit conversions to get the correct answer. And just to get you started too, let's write it out this way. he went 100.00 meters in 9.58 seconds. So that's going to be our first input value. Yep.
For these top ones, would it be alright to collapse them almost? So like writing out 60 seconds equals 1 minute, 60 minutes equals 1 hour. Therefore, 3,600 seconds.
Yeah, you can do it that way. So the question was, can you collapse like the first two unit conversions and say 3,600 seconds are in 1 hour? You can do it that way, but I like showing all my work. That way if I mess up, I can spot where my mistake happened.
Right.
All right, we are running out of time a little bit, so I'm going to walk us through this final one. And I'm just going to pick on meters at first and convert meters ultimately to miles because we know we don't want meters in our final answer. Okay, so let's go ahead and do that. So I'm going to cancel out meters by putting it on the bottom. And then up here, it looks like we've got a relationship between meters and kilometers. So I'll put kilometers on top. We know for every 1 kilometer, we've got 10 to the third meters. And then, now that we've canceled out meters, we can cancel out kilometers. So I'll put kilometers on the bottom. And our next unit conversion up, we can relate kilometers to miles, right? So I'll put miles up here. Say for every 1 mile, it is 1.61 kilometers. Okay, so now I've canceled out kilometers, and I've got the final unit that I want in my final answer, miles for distance. However, I've got seconds down here. We don't want our time unit to be in seconds. What did we want it in? Hours. So now let's go ahead and cancel out our seconds. So this time, should seconds go on the top or the bottom? The top, that way it cancels. Okay, so we'd say seconds goes on the top, and minute would go on the bottom. We're now using this top unit conversion. And we'd say, okay, there are 60 seconds in every 1 minute. Now we can go ahead and cancel out seconds and seconds like that. Okay? But we don't want our final time unit to be in minutes. So I can go ahead and I can say, all right, to cancel out minute, should it be on the top or the bottom? Top, right? Because this one is on the bottom for minutes, we want the canceling unit to be opposite. And then we'd say, all right, hour down here, and we'd say, all right, for every 1 hour, there's 60 minutes. Again, we can cancel out minutes, and this leaves us with our final unit of hours. So if we look at our remaining units, it's miles over hours, which is exactly what we want. So we can go ahead and we can plug this into our calculator. And I'm getting an answer of 23.340555152. Sorry, let me zoom out more. Miles per hour. However, that has way too many sig figs. What's the appropriate number of sig figs that we should have? 3. We started out with 9.58. That has 3 sig figs. Why don't we say that, well, 60 only has 1 sig figs for 60 seconds for 1 minute? What do you think?
For that one, the unit conversion is pure, so to speak.
Yeah, it's absolute.
Exactly.
We didn't measure this. It's an absolute conversion, right? So the fewest number of sig figs we have are with measured values, which in this case was the unit of time that was measured. So it should be 3 sig figs. So the final answer should be 23.3 miles per hour. The thing that blows my mind with Usain Bolt is it isn't the same speed the whole way through. He's actually accelerating, right? When he crosses the finish line, he could get a ticket in a school zone. It's kind of weird to think about. All right, so that's where we'll stop today. The whole problem of the day is just more unit conversion practice. This is really confusing stuff. You're welcome to stop by my office or go to the WTC or email me questions if you want to go over anything.